Hello, my name is Shafronenko Alina, and I want to present to you my article, Adaptive Data Stream Fuzzy Clustering with an Unknown Number of Classes. So, the problem of clustering classification without the teachers is an integral part of data mining and at the same time the most challenging as it implemented in a self-learning mode. Thus is without an external training signal. Solving the problem becomes significantly more complicated if the data sample to be clustered is not provided in traditional batch with a fixed number of observation, but rather is delivered online as data stream that derives one observation at a time, possibly at high frequency. When solving real-world practical problems, the situation often arises in which an observation vector from a data stream can simultaneously belong to two or more classes with varying levels of fuzzy memberships. Such a situation is considered with the framework of fuzzy clustering analysis, which also exists the recurrent online version. And finally, the most challenging situation arises when the data are presented as a stream. The classes are cross-sectional and the total number of classes are known and may change over the time. The most appropriate there is to use an ensembles approach when each member of the ensemble is oriented to a different number of possible fuzzy clustering by but the exciting approach are quite cumbersome from a computational point of view, which makes their use difficult when solving real practical problems. In simplest case, clustering a multidimensional data stream can present it as data stream observation. Let's consider the process of self-learning and self-organized maps that contains M neurons, each of that defines a prototype centroid iode, which is tuned using standard winner-take-all or winner-take-more Kohanen self-learning rules. When the input signal is fed to the MSOM, input vectors x from k for each neurons, firstly the Euclidean distance is calculated as you can see on formulas first. After that, the synaptic weights of the winner are tuned using winner-take-all, the self-learning rule in the formula 2. Compared to the winner-take-all self-learning rule formula first, the winner-take-more rule is more effective using the so-called neighborhood functions, which specify the closeness between each observation x from k and each centroid vector c. Since the choice of these functions is usually subjective, it's convenient to use a similarity measure in the form formula 3. Using the similarity measure formula 3 as neighborhood functions leads a modified Wiener-Tolls-Moore self-learning rule. CJ. It's interesting to know that the in process of self-learning using algorithm to the image X from K, centroid of winners are pulled up iota from K minus 1. A more realistic situation occurs when classes overlap. And observation can belong to multiple classes simultaneously. Within the framework of fuzzy clustering, the most popular method is the fuzzy C-means. Primarily due to its simple numerical implementation, the main disadvantage of this approach its sensitivity to anomalous outliers, which cannot be eliminated when analyzing data streams whose future behavior is difficult to predict. More robust, in this sense, is the method of possibilistic fuzzy clustering, which at the same time suffers from the problem of coincidence, where during the data stream processing classes begin to merge into a single large classes. Their shortcomings are largely eliminated by the credibilistic approach to fuzzy clustering based on theory of credibility, where in the process of processing data sets, not only in the cluster centroids and the level of fuzzy membership of each observation to each cluster are calculated, but also the credibility level in the results obtained. Credibilistic fuzzy clustering algorithms are associated with the minimization function of the criterion formula 3. Typically, in fuzzy credibilistic clustering algorithm, the level of fuzzy membership is determined by the bell-shaped membership function formula 2. So it's in final form, the online stream recurrent version of this algorithm can be rewritten as you can see on these slides. Thus, the ensemble consists of m-1 similar blocks, each of which solves the fuzzy clustering problem for different number of possible classes. In order to obtain the final results, that is to determine how many classes the analyzed sample contains, it's advisable to use one or another clustering quality index. Among such index, one of the simplest and most effective is the so-called partitional coefficient, which is easy to calculate in the form as you can see on this slide. This coefficient has a transparent physical meaning. The better formed the classes, the greater is the value pk. Minimum this value is achieved if the data belong equally to all classes. Clusters are not formed at all. The advantage of using this coefficient is that it is well suited for online calculation when data can arrive with high frequency. As a result of the ensemble's work, a member is selected from for whom PC acquires its maximum value. At the same time, if the sample data stream is non-stationary, stationary and the number of clusters can change over the time, it's an ensemble approach that allows us to detect such change. On next slide, you can see experimental results for medical diagnostics to evaluate the performance efficiently to the developed method and demonstrate its benefits over the analogs. And the experimental study was conducted using a medical data sets. For this analysis, information on diagnostic signs of cancer disease was taken texture, area, smoothness, compactness, so on. The task was previously set to divide patient observation into two classes, benign and malignant tumors, and after processed our algorithms, you can see result. Analyze the sample using the fuzzy data clustering method based on optimization procedure that can work even with those observations that are still completely filed. No signal, no analysis has been performed and analyzing them. Using the proposed method, another cluster was discovered. It's proposed to divide the data sample into three clusters, assess the clustering quality, and analyze each cluster separately. On this slide, you can see demonstrate clustering of the data into three clusters, including observation whose information was analyzed. Analyzing this table, we conduct that the quality of data clustering by the proposed fuzzy clustering methods yields better solution for the relationship between the specific building and its corresponding responsibility class, which currently plays a significant role in planning work on object. It should be noted that the main clustering quality coefficients such as PKSE and XB are more thoroughly attribute this corresponding object to the cluster class, assess the accuracy of assigning a specific observation to the cluster class, thereby removing ambiguity in the object relationship to the cluster. Despite to determine the suitability of water for agriculture use, the type and likelihood of salinity during the prolonged erosion, and to provide recommendation for improving water characteristic and or reducing the negative impact of use. Water samples from the Khaki regional were analyzed depending on the quality of the water and the required degree of treatment of meat. The drinking water indicators water bodies suitable as source for Domestic drinking water supplies are divided into three classes according to the drinking water standards. After cluster analysis was performed, using the data stream recovery and filtering method under condition of increasing clusters, recommendations are provided to improve the characteristic and eliminate the negative impact of its use, depending on the class in accordance with drinking water standards. The method's quality was assessed using clustering quality indicators. On table, you can see experimental results. The proposed narrow fuzzy ensembles provide synergetics effects to combine the approximating capabilities of neural networks with the transparency of fuzzy logic. This allows us to recommend it as the most reliable, most credibility tool for intelligence data analysis in decision support system when high classification accuracy with minimal entropy of results is critically important. So, by contributing repeat lines of learning with credibility trust, this architecture provides the highest classification accuracy with minimal entropy. It's the ideal tool for intelligent decision support system operating in volatile high-frequency environments. The problem of fuzzy clustering of data streams is considered under the condition when information is received online, possibly in real time, and the number of clusters is a priori unknown. It's proposed to use an ensemble of subsystems operating in parallel, each solving the fuzzy clustering problem online and designing for a different number of possible clusters. In this case, each subsystem solves the fuzzy trust clustering problem, and the quality of the result obtained is accessed using the fuzzy partition coefficient. It's assumed that the number of clusters during the data processing can change arbitrarily. The proposed approach is computationally simple and intended for processing data that arrives at high frequency and can change its properties. So the work is supported by the state budget scientific research project of Hacking National University of Radio Electronics, adaptive bagging of hybrid computational intelligence system based on speed optimal online learning. Thank you for your attention.